right, about 10:30, so we'll go ahead and get started. Thanks so much for showing up. I'm flattered. They put me head-to-head with Space Road, and I really wanted to see his talk too, so I was sort of doubly disappointed that I got to compete with somebody with that kind of great game recognition, and I missed out on the talk. But luckily they're recording these talks, so hopefully we'll be able to go back online and be able to catch that one as well. So my name is Keane. I work at a company called ThingWorks that makes IoT developer toolkits. I am here in a personal capacity. I represent my company. I may say things that would offend people in my company, so just keep that in mind. These are solely my opinions on IoT security. I've been working in the field for about 7 months, so this is relatively new to me, so these are a lot of lessons learned that I've picked up in my short time in Internet of Things security. I'm going to try and sort of make this talk as much your talk as you want. So if you have questions about anything that I say, please throw up a hand and I'll take a pause and feel free to answer your questions. I've saved some time at the end for questions as well. But I sort of thought a good way to frame this discussion would be around this project that I've just recently gotten involved in, which is the OWASP IoT project. So this project was started up by two guys who used to be, well, they both used to be at HP, and one of them still is, Dan Messler and Craig Smith. They worked at HP doing basically an evaluation of IoT products and produced a white paper, and out of the findings of that white paper, they sort of came up with a list of top 10 IoT vulnerabilities and attack surfaces, and by the time I found them, I come from a developer background, so I found the project and was sort of looking at ways to find resources for people who are building IoT systems and sort of ways that we could sort of enable those folks to give them good best practices, toolkits, frameworks, solutions, so that we wouldn't constantly be repeating this sort of train wreck of mistakes that we're seeing right now in IoT. So it's really hard to sort of define what Internet of Things is, right? This is it may surprise folks to learn, but this is a marketing buzzword and not really a specific technology. So this is a really broad field that you can kind of pick and choose in between of what you're doing, or how you would define it. I would say the key differentiator is the first sort of phase of Internet of Things was just Internet-controlled devices, right? So these were devices that you maybe hooked up to the Internet so they could reach command and control, and you could use your phone to like open and close your garage door opener. And that was sort of like the earliest evolution of Internet of Things. What we're moving towards is Internet of Things consisting of autonomous devices that can talk to one another, right? So machine-to-machine or end-to-end communications, as well as with the users, with a central hub, distributing information, doing things like mesh networking, and carrying out much more complex sort of analytics and autonomous tasks than just turning on your coffee pot when you wake up using your cell phone. So most people think about Internet of Things security, and they think about these kinds of incidents, right? Your hacked baby monitors, or Charlie Miller, Chris Balsack's research just destroying cheap, or any of the work that Sammy Kamkar has done. So if you're not familiar with any of these stories, you should go check them out. They're kind of amusing. They sort of led folks like Dave Eichel to call this junk hacking, right? That there's all these people going to the garage, finding internet-connected stuff, and just ripping it apart and finding security holes. The reality is, when you look at most of these hardware hacking or other IoT hacking stories and sort of media covered events, they tend to be consumer focused, and I think that sort of creates an unfair playing field for IoT, right? If you're developing an IoT solution for a consumer, right, a home consumer especially, you're basically considering that you're going to deploy this device into like an area of limited connectivity, potentially a trusted network, right, a homeland, something like that. And you're selling to people that want features. They don't really care about security, right? Like my wife got me an Apple Watch for my birthday, and I was like, this is awesome. I don't even care if it's secure, right? Like, it just does neat stuff. And that's what the consumers who are looking at these IoT deployments are looking for, right? They just want the Nests to automatically adjust their temperature while they're driving down the road. They don't really care that it might be exfiltrating sensitive data from inside their house, right? So unfortunately, the manufacturers of this class of IoT don't really care about security because they know it's not really going to be a market differentiator, and it's not really going to hurt their sales if they have a bad security track record, except maybe arguably in the case of Jeep, where that's going to cost them more. Where we really want to be focusing our efforts when we're thinking about IoT security are these realms of IoT, right? So this is industrial IoT, this is manufacturing IoT, this is municipal IoT, this is IoT in healthcare, right? So these are connected devices that exist in businesses, right? So companies like, John Deere or Caterpillar or, Siemens, like these are big, companies that are producing very expensive, very complex pieces of physical hardware that want to connect these devices to the internet and connect the devices to one another, right? And so the security challenges around this class of IoT share a lot in common with consumer IoT, but I think it's going to be it's a tougher nut to crack, right? First of all, hopefully these deployments are going to be much larger and face a lot more security scrutiny, but ultimately with the OWASP IoT project, these are the kinds of deployments that we're looking for. So if you're a builder, I think you should be able to get some good information about the next few slides. If you're a breaker, though, you're probably going to see a lot of stuff that you could use to maybe test these kinds of systems as well. I'm going to point out like a lot of common failures in these kinds of systems and so on and so forth that you can use in your own environment. I would encourage you, if you want to get into this field, to start ripping up some consumer IoT stuff. It's going to be an easy playground for you. You're not going to face a whole lot of resistance from those devices. But once you decide to get serious, moving into this realm is definitely the place to go. So why are these organizations doing this? Right? Like, if you talk to most security people and you say, hey, my business is thinking about hooking everything up to the internet, right? We're going to hook our water sensors up and maybe our pressure sensors and maybe the valve controls in our nuclear facility. Your security people are going to say you're a moron. Like, why would you do that? That's idiotic. Please don't. The reality is there's a very compelling business case to do all of this, right? So if you, as a business owner, can collect and aggregate data about all of the various components in your business, you can make all sorts of really interesting decisions based on that data that can have a very real financial impact on your company, right? So UPS is like one of the poster children for IoT in industry, right? So they have sensors on all of their trucks, and those sensors are recording all sorts of things like tire pressure, fuel levels, oil levels, maintenance times, locations, and they're using these for routing and things like that, but they're also using them to do what's called predictive analytics, and they're looking at the data coming back from their fleet of trucks and trying to spot patterns that will indicate that a truck is going to break down. And then they'll perform preventative maintenance on the truck, right? So this is a clear win for UPS, right? If they can get to a truck before the fuel runs low and the engine blows up, they can save themselves a lot of money. Not only that, but they can plan their repair cycles, in sort of ways that will prevent a sudden influx of trucks that need to be repaired in a backlog, right? So this kind of like data analytics and business process optimizations are really, really attractive for businesses, and that's why they're going to move to IoT despite the security concerns, right? They're definitely going to be aware of them, but they're going to do it anyway because there's a lot of money to be made here. And I think it was like the latest Harvard Business Review focused specifically on the financial wins from going to IoT. So it's definitely coming. The other neat thing that you can do with IoT, right, is with a traditional device, it might be collecting a lot of data, but typically you have to go to the device to extract that data, like think like maybe an MRI machine or something like that, right? So this is data that would be very valuable to a large number of people, but it really only has one interface. If you connect that device to the internet, then what you can do is you can parcel out access to the data from that device and give different pieces of the data to different people based on authorization models. So this is really clear to see in healthcare environments, right? Where you might have like, some sort of healthcare machine that's collecting data from a patient. And that data might be useful for the patient, just for their own healthcare records. It might be useful for the doctor for making diagnoses. It might be useful for the nurses or the other medical staff on the floor for monitoring what's going on with that particular patient. It might be useful to the manufacturer of the device to do this kind of sort of preventive maintenance and predictive analytics. And or maybe even the technician who's going to come in and service the device and maybe spot problems and repair it. But obviously you don't want to be giving all the data to all of those people, right? But as soon as you get into an IoT environment, you can take all this data off of the device, put it in some sort of repository, and then enforce, authentication and access, schemas that will allow the various different people to get access to the various data and to share remotely, right? So this is a huge promise in healthcare, right? Like I could get an MRI scan done in one hospital, and I could get a second opinion on my condition at a totally different hospital because they can access my electronic medical records. And so this extends all the way through other areas of commercial IoT, not just healthcare, but it's probably the most visible. So, shifting focus why we're going to use IoT to why is IoT security so bad, the essential problem behind Internet of Things security is it's an evolutionary technology, right? So IoT sits on top of a stack. And you can think of all of these other layers here as supporting Internet of Things. In an Internet of Things deployment, you don't just make a singular system, you really build an ecosystem, right? So you have a device and it's collecting some sort of a data, and then you need to do something with that data. Well, so how are you going to do that? Well, first of all, we're going to have to connect the device to the network so that we can get the data off the device. The device might not even be powerful enough to do like regular TCP/IP networking, so we might need to connect it to something like Bluetooth Low Energy or Zigbee or wireless protocol to get the information to some other device that can broker it off to the internet. You've got all of the problems of the device is built on a specific piece of hardware, and what does the hardware security look like? Typically, most IoT deployments are using like run-of-the-mill operating systems like Windows Embedded, CE, Windows 10, Linux, something like that. All of those operating system challenges that we've dealt with for decades suddenly manifest inside of IoT. We're connecting it to the network, so we've got all the network security challenges. Are we encrypting stuff on the network? Are the devices able to do something like TLS security? What if they're not powerful enough to do complex encryption? Then how do we protect messages across the network from these devices? Do we develop custom protocols and hassle with firewalls? Well, the answer clearly to this point has been no. Firewalls basically block everything but port 80, so we're doing all of this over like web traffic, basically. And as soon as you're throwing something over port 80, we're going to send it to a web service and some sort of RESTful API that's probably going to be living in the cloud somewhere. So we've got all our cloud security deployments on top of that. Any sort of mobile access to the ecosystem is also going to have to be considered. And so IoT is building on all of this, right? And I think this is why everybody intrinsically knows IoT security is bad, right? Because I could point to any of these and be like, how do you feel mobile security is doing these days? I mean, like, it sucks, right? Well, what about operating system security? I don't know. I got 3 critical patches from Microsoft on Tuesday, and my laptop still crashes, right? We're doing terrible at it. And we're building on top of all of this, making an incredibly complex system that's going to rely on all of these pieces of their interconnection. So it's clear to see why it would be bad, and here is why we see so much evidence of things being bad, right? So in IoT, we basically have testers who are coming in who are looking at the various components of this IoT stack, and they've got really well-developed tools with a long history behind them, and they're using these tools to just tear apart IoT solutions and find problems with cloud infrastructure, with mobile infrastructure, with your operating system setup, with hardware. All of these things are going wrong. On the flip side, we basically have the builders. So these are the developers who see the value and the money in IoT, right? So they want businesses to recognize the value of IoT, or they recognize that they build the next Nest thermostat, they're going to be instant billionaires. And so they're trying to get into this field, and there's no real good guidelines for these people, right? There's no sort of like industry recommendation. Oh, hey, you're doing IoT? Use the secure IoT framework here. It'll suit you right. Or use this software and hardware stack. This is the one that will prevent you from running into problems. And so generally what developers are doing is they're just running out and grabbing whatever they can find and cobbling together solutions and just sort of sticking in on hardware that works, right? They say like, well, Raspberry Pi is pretty cheap. I can grab one of those, and maybe I can throw some Ubuntu on top of that, and maybe I'll use some Bluetooth in there, and then I'll just send some RESTful API calls back and forth, and I'll hook up a sensor on it. And they'll make really cool stuff, but there's never any consideration of security in the procurement of any of those elements, and there's certainly no consideration given to what are the security implications of the interaction of all of these different elements and hooking all of this stuff up together. And so as a result, basically, we have developers building really fragile solutions that fall over very quickly in the face of scrutiny from the security community. So I mentioned the Hewlett-Packard research study. It's pretty easy to find. I think Internet of Things research study, and I think they studied, I don't know, anywhere between 10 or like 50 different, I think maybe it was 10 or 12, IoT devices. They tended to be mostly consumer devices, right? So these were devices that you would actually find in the home. So it doesn't necessarily make it better because people tend to take these home things off to work and hook them up to a work network too. So it's not necessarily making anything better. But the reality is they were mainly testing stuff that you could go down to Best Buy and pick one up. And I've been talking to these guys, and they really are very interested in getting into like industrial IoT testing to see like what is the state of affairs there. The problem is in most industries you have what's called a brownfield deployment, right? So a greenfield deployment is you have a situation, you have a problem you want to solve. You step in as the architect, the technologist, and you say like, here's how we're going to do it. Soup to nuts. We're going to build it this way. We're going to deploy it. The reality is, in most industry, industrialists will come to architects and say, like, I've already got all this machinery and infrastructure. I've got some SCADA systems. I've got some other monitoring systems. I've got some internet connectivity, some stuff. I need to hook it all together, and I need to get it into some sort of analytics platform, right? So solutions providers in this space are working with heterogeneous solutions. They're sort of saying, like, well, we'll take a little bit of this and put it here, a little bit of this and put it here. We'll do some of this over here. We'll hook it up maybe over some standard protocols like HTTPS, something like that, aggregate it in a central data point, but ultimately the ecosystem is non-homogeneous, right? It's all sorts of different things all over the place, and so you can't easily step into that environment as a tester and say, like, oh, hey, GE's smart factory is insecure in these ways, because it's like, well, maybe a couple components are, but not the whole thing. The other thing is you can't just like go down to Best Buy and buy like a smart factory and check it out and test it. So we don't see much in the media about security researchers reporting on problems, generally because if they do get a chance to look at these systems, they're under NDA and contract with whatever company hired them, so those results never go public. The one organization that has done some sort of public testing is the Securing Smart Cities, and that's led by Cesar Cerruto out of Argentina. He might be at Kinetics. But he managed to get a hold of a smart traffic metering system that basically had sensors that you put on the roadways to track traffic and smart traffic lights that would adjust that based on the volume of traffic. And so it was really interesting, and no surprise, he found problems in the wireless protocols used by the sensors, trading messages, there was no authentication, you could give them updates that weren't validated, so you could put a malicious update, so on and so forth. And he basically found out ways that you could do really evil stuff with these traffic sensors. But that's like the one case of sort of industrial, or in this case it was municipal IoT that I'm aware of, where a professional tester actually got to test stuff and produced some really, really amazing results. And I think, even though we might not hear much about industrial IoT or commercial IoT being bad, I think it's not because it's good, it's because we don't have the research really to make it an application. So if you get into this space, I think we would find that industrial IoT is just as bad as So into this mix steps the OWASP IoT project, right? We're a bunch of idealistic guys involved in IoT, and we think, hey, we're going to make a difference. We quickly realized that IoT is massive, and that the IoT project really, by necessity, had to be an umbrella group. So there's a number of different things that we're doing. We're sort of, actually, it's mostly like Dan and Craig are doing these top two, enumerating attack surfaces and vulnerability lists. Unfortunately, like Google still throws the OWASP IoT top 10 at the first, that's your first search result. So if you're searching for OWASP Internet of Things, go to the second result. That's actually the project page, not the top 10. We're also looking on developing some reference solutions and architectures that we can give to developers to sort of say, if you're developing IoT, this is the way to do it securely. And to support that effort, what we're really trying to do is we're trying to develop these last two things. So we're trying to develop some sort of implementation agnostic principles of security to think about when you're working in IoT, and an IoT framework assessment. So in a typical web development environment, one of the sort of canonical pieces of advice that you give to web developers is like, don't build your own web app. Like, go out and get a framework, use something like Django or Drupal or whatever you want to use. Make sure it's got security mitigations against like the OWASP top 10 and all those things, and build off of that. And then that way your developers don't have to think about the problems. There are actually IoT frameworks that are out there that you can develop IoT solutions on. They're pretty new to the market, but we wanted to create a checklist that basically said, like, if you're asking somebody about this IoT framework, you should ask this question, and this question, and this question, and this question. So if you're involved in an organization thinking about IoT, I would highly recommend that. If you're involved in testing IoT, I would also recommend it, because basically all of the questions are very leading. It's sort of like, do you do device-side encryption? If the answer is no, and you're a tester, that is a potential avenue for attack, right? So it's designed as sort of a checklist for people doing evaluation, but I think you can pretty easily use it as a pen tester, as a checklist of like ways to break in the system. We also aggregate a lot of the community resources that we found around IoT. I think this is a growing community. And as I go through this talk, if you see something that you think should be a part of our material, or you think that you can make a contribution, please reach out to us. Come to our website. We're looking for contributors. So it's definitely an evolving project. So here's the OWASP IoT Top 10, and the categories are accurate, but I've abbreviated the security considerations and recommendations just for the sake of squashing them. I'm sure you can all read this, right? So I'll run through them so you don't have to squint. But this is very similar to like the OWASP Top 10, right? So these are vulnerabilities that testers typically find in IoT deployment, sort of ranked in terms of like the most prolific, highest impact to the less prolific, less impact. So the number one problem that we find in IoT is insecure web interfaces. And part of the reason why you find this is because most people rolling IoT are very concerned about resource constraints, right? They want a very small footprint on their firmware, on the devices. And so instead of using a web application development framework, something like Django or something like that, they're rolling their own, right? So they're writing CGI scripts in C and C++ and putting them on the web in a web interface for their IoT deployment, and you can imagine all the things that go wrong there, right? Like you've got buffer overflow vulnerabilities in your web interface all of a sudden. And again, these are developers intent on standing up IoT solutions. So it's not like they're doing anything dumb or stupid or foolish. They're feature focused, right? They want to deliver value to the customer. They don't really think about security, and frankly, there just aren't enough security people involved in IoT to tell them otherwise. Yeah.
They also develop EULAs that make it your responsibility to secure the environment.
Yes.
Especially in the SOHO market, which you're discussing the SOHO market, but that also ends up in your industrial areas, in your kitchenettes and all of your light bulbs and devices and the like.
That is, yes, that's exactly true. And a lot of manufacturers will use that as an out. Yep. But basically, if you ask them probing questions about like, do you do bidirectional encryption between clients and a central server, the vendors will say like, no. If you want to set that up, you can, but we don't do it, right? So you'll see a lot of deployments exactly where they're sort of like, that's an operational consideration, right? Like that's not what we do. We give you the solution, you make it secure. You've got your own security department. I think luckily the rush to sort of like cloud-based deployments has changed that model slightly because now suddenly vendors are responsible for the core of the ecosystem, but a lot of companies, again, wants to host in-house, and so they accept that responsibility. So yeah, so that's a huge area of IoT security that, again, it's not necessarily IoT specific even. It's just like you're bringing new systems into your ecosystem. You might be responsible for certain risk that may or may not be explicit to you, right? Like unless you read through the EULA and you're like, oh geez, I can't believe I'm responsible for that. So yeah, definitely. So the second one is insufficient authentication or authorization, right? So this is either like no usernames and passwords on interfaces, default usernames and passwords on interfaces, easily guessable interfaces on usernames and passwords. These are big or classic brute force attacks where you find some SSH or telnet or web interface on the IoT device and you type in admin and suddenly get dropped to a root shell. It's like, over there. Insecure network services is a big one, and I'm going to talk about this one a little bit later, but basically utilizing network services that don't have a security component. And this sort of comes up as part of the framework assessment, but one of the first things that you want to do if you're testing an IoT device is take it into a hostile environment, which basically means like rip it out of its ecosystem and put it in one that you control, right? And most developers don't consider that. Like they never think about like, well, what if somebody hijacks DNS? It's like, well, you're responsible for your DNS infrastructure, so I could do that. But that's the first thing a tester is going to do, is say, like, what queries is this device making, and can I misdirect it, right? Can I attempt to degrade any encryption that's applied? Can I get access to any of the information? And, probably not shockingly, a lot of IoT deployments won't even bother using encryption in a lot of transport. Especially if you're talking about the transport that's close to the device, so if they're using like Bluetooth Low Energy or Zigbee or something like that, a lot of times you'll find that there's not even any protections applied, because basically the thought is, as an attacker, you would have to have physical access or be very close proximately to the device, which is not all that hard in an IoT environment. So we find like lack of transport encryption, privacy concerns. This is a huge one that's sort of like closely related that I'll kind of touch on a little bit. It's not entirely my focus. I think privacy in the IoT space is a really tricky challenge. Because there's not really many good technical solutions, right? Like there's not like a privacy module that you can like slap on your IoT solution and have it be okay. The other thing about privacy in an IoT environment is like most IoT deployments are designed to like collect data about their environment, right? So you have things like sensors that are just sort of aggregating what's going on around them. And part of the reason this is a problem for privacy is in a typical or sort of like a traditional application security model, when you sit down and you use an app, like you log in, you start up that app, there's some sort of explicit security contract that you make with that application, right? Like you interact with it, you start it. In IoT, you might just be walking by a device, right? You might never be aware the device is collecting any information about you. You certainly don't have any opportunity to consent to that collection. And in the most frightening cases, there might be instances in IoT where people who are legally not able to provide consent about data collection, minors, being exposed to these IoT environments, right? So this is data that's all getting sucked up. And oftentimes without the consumer's knowledge or the customer's knowledge. Insecure cloud interface, insecure mobile interface, pretty typical stuff. Insufficient security configurability. So this is another one. This is a problem with IoT because a lot of IoT devices don't have any human user interactions, right? Like they don't have an interface for people. So it's very difficult for a person to understand what is the device doing, does it need an update, how do I update it, what's the security posture of the device, you know, do I need to update firmware, how would that happen, do I even know? And you know, this ties into number 9, which is insecure software or firmware. So this is typically IoT devices that will allow you to, side load or load firmware updates onto the device, and they won't check whether those updates or those additional software components are valid and should actually be on the device. And lastly, it's more physical security, right? So this is the hardware hacking where you actually just crack the case off of things, and you start looking at chips, and you start pulling out, flash memory, and just taking a look at it, and using, tools like binwalk to uncover what's going on inside the device. Or these devices sometimes will have USB or Ethernet ports that will give privileged access. They'll have like JTAG interfaces that aren't disabled when they go to production. All of those things are big problems. So we looked at all of that, and we tried to develop an IoT list of principles of security. And so these are sort of designed to be kind of markety, and they're supposed to be the kinds of things that you should present to your developers or your CTOs when they're sort of thinking about doing an IoT deployment, and what are the kinds of things that you need to keep in the back of your mind about the problems that are going to crop up at your IoT deployment. So the first thing you need to do is assume a hostile net, right? So the idea here is that you deploy your IoT devices into a physical environment that's beyond your control, right? And you need to consider the implications of that, right? So as a tester, this is the thing, right? Again, the first thing you do, you take the device and put it in a hostile environment, you start breaking it open and see what happens. I think a lot of developers don't really consider that, right? They don't consider that somebody might actually open the device up. They might intercept networking traffic. They might interrupt networking traffic to see what happens, right? They might change out components. They may try and download firmware and run it in a virtualized environment that they control. So you always have to consider whatever you're deploying on your edge is deploying into a hostile network. And you see this, where this causes the most problems is people put stuff like authentication credentials into software that goes onto devices at the edge, right? Because you're basically writing down usernames and passwords. Maybe you might try and obfuscate it, but you're putting that somewhere on a device and then you're giving that device to somebody, right? So then it becomes very easy for them to try and pick apart that device and find those authentication credentials. So you need to be really careful about what you're doing. You'll see if you go online and you search for private key exposure incidents, you see a lot of people, not necessarily specifically in IoT, but in sort of deployment environments, where manufacturers will unintentionally put very sensitive cryptographic material on devices and maybe not unique cryptographic material. So so they deploy 100,000 routers, and not that Cisco may have done this, and you put the same private key on there, right? And so as soon as somebody recovers one private key, they suddenly can break down your entire cryptographic infrastructure. You want to test for scale, right? So the security problems in IoT are really exacerbated by scale. Even simple things like denial of service. With IoT deployments, you're typically talking about maybe a couple thousand to a couple million devices in an ecosystem, all talking at the same time. And you can imagine the problems that are inherent there. Even something simple like self-registration, right? So you buy a new smart connected toaster and you turn it on. Well, how does that thing register to whatever cloud service that it connects to? No, can you spot a malicious registration? What if you make a device and you deploy it on a factory floor and a million of them all turn on at the same time, right? You can create a self-denial of service condition right there. The Internet of Lies is like one of my favorite little principles to apply to IoT, and I thank God for Volkswagen for like making this little thing for me, right? IoT are autonomous systems, right? They're capable of making autonomous decisions and reporting information autonomously, and they might not be reporting the truth, right? Just because you see that a diesel motor says, yep, I'm running clean in the lab, doesn't necessarily mean it is running clean in the street. Everybody, if you don't know about Volkswagen's little machinations, you should look that up because it's just kind of brilliant. And it's really basically using software to feed false information. And in Internet of Things, because you have so many autonomous devices, it oftentimes becomes really difficult to tell if a device is compromised, if it's acting maliciously, if it's really sending you what you need to send. And if you don't believe that that's the case, just read Ken Zetter's book about Stuxnet and how those little PLC devices reporting that everything's great here while they're destroying centrifuges in Iran. You need to exploit autonomy. So in IoT, devices are operating independently of one another, but they're also capable of operating independently of one another and doing very complex computational and cryptographic tasks. You need to recognize that the device is a full computer, right? And so don't fall back on models of like using usernames and passwords for devices to authenticate one another. There's no reason a device can't have like a 2 megabyte cryptographic certificate that it can present as its authentication credential, right? So you can use this autonomy to make devices do things that human users would never do, right? Like they would just never deal with all of that. And you can also use it to enforce those kinds of constraints, right? Like an autonomous device is never going to get an SSL cert warning and say, yeah, click through, add to exception list, right? Like it will actually follow these sorts of rules that you can enforce. You need to expect isolation too. So this is sort of my favorite. In a lot of IoT deployments, if you take a device and you remove its networking capability or you cut out a specific piece of the ecosystem that it expects to be able to communicate with, it'll like fail open. It'll basically just, security mechanisms will go away, right? And they won't sort of enforce the same security posture when they're disconnected as when they're connected, right? So like what happens to these devices if you cut the internet connection? Do you suddenly not need to authenticate anymore because it can't authenticate you to a central service? Who knows? You need to protect uniformly. So when I talk about the IoT ecosystem and all of the different components in there, a lot of times what you'll see is you'll see designers build very strong protection capabilities in areas where they feel like people will try and attack them, right? So they'll make like complex multi-factor authentication via the web interface to see the metrics and control the devices in the IoT ecosystem. And they'll forget that there's a mobile app that allows you to enter a 4-digit PIN and get access to the exact same thing. And the mobile app isn't talking some like magical protocol. It's talking over the same, and all an attacker needs to do is find that mobile interface. And suddenly, the challenge of breaking in goes from complex multi-factor to 4-digit PIN, right? So when you think about IoT ecosystems, you need to think about like, what are the protection mechanisms that are applied, and are they applied everywhere? Do you have a uniform defensive surface? Encryption is tricky, and I see this a lot working with developers. That like a lot of developers recognize like, hey, encryption is the answer, and they sort of like sprinkle crypto dust on stuff. And then you come in and you're like, why are you encrypting like a post parameter in a URL? Like, who cares? You're like, it's AES 128 encrypted. Like, we're good for the auditors. Like, it doesn't really do anything. And you can find problems where people will do stuff like they'll salt password hashes, but they'll use the same salt for every password, right? Like, it's very easy to make mistakes with encryption, and this is one that you don't normally see pen testers poke at when they're sort of attacking IoT systems, generally because they don't have to get to this level. But it's been my experience when you look at the encryption deployed in IoT systems, typically there are mistakes that basically invalidate the value of the cryptographic defenses. You need to make sure you do system hardening at every level of the stack, right? So you could have a really awesome IoT deployment, but you could have an SSH service onto the Linux box that's running the edge, and you can have like the password for the root account be like password 123 or something like that. You need to make sure that you're following all the traditional system hardening for all of the various components of your infrastructure, really. Not just the hardware, not just the networking, also your cloud, right? Like the worst thing you want to have is you could have a bunch of really hardened virtual machines sitting up in AWS, but your management interface could have like a bad username and password, and somebody could just pop right in through the back door that way. You need to limit what you can. So in the rush to produce, product for the IoT market, features sell, and people basically want to build a bunch of features. The reality is there's no reason to ship with all those features turned on. Like to turn off as many as you can. And this is another avenue of attack, is to sort of see like, what are the unused or unadvertised features in this ecosystem, and can I take advantage of them and bring them? Full lifecycle support, you need to plan for compromise, you need to plan for being able to revoke certain devices, you need to plan for updates. I don't know if anybody's familiar with like the Wink Home Hub, but they had a really bad problem, like one of their SSL certificates expired, and then suddenly like none of their customers could receive updates and everything failed to be able to integrate anymore. And they hadn't planned for lifecycle support. They hadn't planned for like, well, what do we do if you need to update like your root certificate trust score there? And so they did pretty much what Jeep did. They started mailing out USB keys to people, saying, like, or bring them back into the shop. And I think if Wink is not out of business now, it's like it's a chapter. I don't think that incident helped them. Data in aggregate is unpredictable. This goes back to the principle, the privacy. Everyone sees the value of collecting data in IoT, but very few people are thinking about the privacy implications of collecting that data. And I really like to talk about the example of, say, you're a manufacturer of a tire pressure sensor, right? You want this to be a smart tire pressure sensor, so you want it to report back to home. And you want to aggregate all this data and combine it with other information from a car. Maybe, maybe not. But let's just assume the tire pressure sensor, like men fluid dynamics, is bad. Let's just assume, for the sake of argument, that I know what I'm talking about in physics. And you could tell, based on changes in tire pressure, where the car was located, say, in terms of altitude, how long it had been driven or when it was being driven due to pressure, due to temperature changes, and how much load was actually in the vehicle. So you could tell like how much the vehicle was carrying, when it was being driven, and changes in altitude. Even with just this basic data. Most people would sort of think, well, that's pretty innocuous, like who cares, especially if I aggregate that. But what if I'm watching like one car over the course of 2 years, and I notice that this car has a certain weight ratio or whatever, and it steadily increases, say by like 4 or 5 pounds, and then suddenly overnight it goes to an overall weight increase of 12 pounds. You might be able to assume that the person who owns that car had a baby, right? Like maybe there was a woman driving that car and she slowly gained weight over the time of her pregnancy, and then she added a baby and a car seat to the back seat, right? That's data that those people would never consider that they would be stewards of. And you really see problems with this, like the Ashley Madison hack. I mean, everybody was sort of like up and on to them. It's very sensational. Like, of course, people are going to get divorced. One of the fallouts of the exposure of the users for Ashley Madison was there were people who sort of came out and said, I engaged in activity on Ashley Madison that could get me the death penalty where I live. And I'm sure that Ashley Madison, in designing their risk matrix, never considered that they might hold data that could get people killed, right? And so when we're aggregating this kind of stuff, especially in an IoT environment, especially at scale that IoT runs, especially considering we're using sensors that may or may not even allow people to opt in for participation, we need to think very clearly and carefully about what are the privacy and security implications of having it. You need to plan for the worst. You need to assume that eventually you're going to get compromised. And what are you going to do with it? You don't want to be sending out a whole bunch of USB keys. That's going to be awful. The long haul is an interesting one. So most commercial IoT deployments are anywhere between like 4 and 20 years, right? So you're designing a system that you're going to put in the field, and it's going to have to last. And so it's really important for developers to deploy what I like to call forward-compatible security, right? So new attack vectors are going to be discovered, new defensive capabilities and cryptographic capabilities are going to come out, and if your system is sort of deployed point in time and it can't be upgraded and it can't be adjusted, you're going to run into problems really quickly. Because 2, 3, 4 years down the line, your systems are basically going to be degrading in the face of advancing attacks. Transitive ownership is one that I like to talk about that nobody seems to be thinking about. Like, so I build a smart home, and then I sell it. Well, like, what happens to all my smart devices? Like, do I have to go and like rip them all out of the wall? Now you suddenly find my Nest settings, and you can take apart my security. Like, what do I do with that? Not only that, in an industrial space, you'll oftentimes find companies with smart connected products that use the same products in the same vertical amongst competitive entities. So you might have somebody that has like a smart vending machine, right? And say they work for a Coke distributor and they decide like they don't like that vending machine or it's getting old and they want to sell it. Can a Pepsi distributor buy that machine and pull out proprietary data from that machine, right? Like, so what computational power is moving along with this transitive device, and can you protect it? Yeah.
Speaking of smart homes, there was actually a situation that just happened with an individual who was married, He got divorced from his wife. She married a new person, and he still had connectivity via his
Nice.
device to the house and tortured them in the house by changing the AC in the middle of the night, putting on speakers, flashing lights.
Yep.
She had no means of revoking it
Yep.
from him
Yep.
because the vendor never put it in.
Right, because most manufacturers don't think about that. They don't think like, well, what do I do when this thing gets sold? Like, how do I?
You went on to post comments on Amazon about how he did that on the
Oh,
actual
man.
price.
Yeah, he did. He actually he was unabashed about it. He's like,
Yeah.
I'm doing it.
Well, this is the crazy thing. You sort of see the consumers leading the bleeding edge here in terms of information reporting, but this is happening on an industrial level too. Like one of the big concerns with a lot of industrial clients is, let's say I want to use strong cryptographic capabilities on my edge, so I go to somebody like Symantec or VeriSign and I buy cryptographic certificates that I deploy on each of my edge devices. Well, those aren't cheap. What happens if I sell that device? Do I get that cert back? Like, does that cert go to my competitor? Like, how do I deprovision that? And you'll find answers from industry, and they're like, oh, well, we've got like an online certificate status protocol that'll allow you to sort of say like these certificates. Well, at IoT scale, it doesn't work, right? Like, you can't have an IoT device pull down a certificate revocation list that's 2 million records long and parse it, right? Like, it just can't do it. So again, scale becomes an issue. And this last one is one of my favorites, and it's one of these problems that like there's no good solution, right? So in traditional computing systems, we have like maybe a one-to-one or a one-to-many relationship between an application and a user, right? So you might have an application that has multiple different users, but you just have the one application. In IoT, you don't have a one device to one user relationship, right? You have a device that might be used by multiple different people. You have multiple different people that might be using multiple different devices. You might have devices that need to broker credentials that sort of operate, say like, I'm talking to another device, but I'm going to use Joe's credentials to do this because Joe is trusted on this other device. There's no good authentication mechanism for that. Like, you want to talk about like crazy authentication schemes? How do you do that, right? How do you credential individuals to devices in this kind of a scale, in this kind of a way? And these people are going to need different permissions on different devices, right? We have no good, even academic models, I don't think, as far as I'm aware, to solve this problem. Like, how do we do lattice authentication between devices? And that's causing all sorts of problems. Again, where you're just finding devices doing sloppy authentication or insufficient authentication or running into all sorts of authentication mistakes. So the last thing I kind of wanted to talk about was the framework assessment that we started to set up, and we developed it based on a model of this sort of like prototypical IoT deployment where you have like your smart coffee machine for whatever reason, and it's connected to the internet, and typically it's going to use some sort of a gateway device, right? So this may or may not always be the case, but a lot of times you'll find that. You have some sort of cloudy infrastructure that's doing sort of aggregation. This could be like an on-prem thing, or it could be something that's like publicly available. And then you have some mobile component that may be talking either to the gateway, or to the cloud, or to the edge component. So we basically broke it down into security questions you should ask about the edge, the gateway, the cloud, and the mobile component. And I just sort of pulled like a few of the ones that I thought were most interesting off of there. But when you're talking to vendors of IoT framework solutions, you need to be asking these things. And if you're a tester and you're looking at an IoT deployment and you're looking at like the edge, these are the kinds of questions you need to be asking because it can very well guide your research. And so again, this is not a comprehensive list. Like, go to the website and there's like 20 or 30 of these different questions. And again, we're always looking for feedback. So if you have questions that you think you would ask that aren't asked, please let us know. But so on the edge, you want to know, like, is communication encrypted? Is storage encrypted? And if it's not, why not? Like, that should be a problem. Does the edge device do any logging? Where does it store those logs? If it stores it locally, that might not have a whole lot of value. Are they shipped off to like some sort of central aggregation point? How are those logs protected? Did somebody intercept them? Can they tamper with them? Can they change them? Is there an updating device, updating mechanism for the edge? Can I tell what version of software is running at the edge? Does it automatically update? Does it at least report to me that I need to update that edge? If I do want to do an update, how does that happen? Does it reach out over HTTP and just grab whatever binary is off of a content distribution network? Or does it actually go and find something off of an authenticated site, download it, check some sort of cryptographic signature before it installs it, right? Are there default passwords, and you find this everywhere? Or are there shared passwords, right? So even if you're not using a default password, if you're sharing a password across an entire infrastructure, you're basically setting your own cell phone for failure. What are the offline security features, right? So if I pull this device and I kill all its internet connectivity, what does it do to defend itself? What happens when it comes back online? Will it do stuff like cache logs and then forward them when it comes back online, or will it just fall over? And how is transient ownership addressed? The gateway, you have a lot of sort of similar concerns. A lot of gateways will perform encryption or secure protocols on one side, but not the other. And figuring out like whether or not there's support there for encryption edge to end, whether or not the gateway breaks encryption, right? So you could have a gateway device that's gathering things from an encrypted communication on one side and sending them out to the similar encryption on the other side. But if an attacker sits on the gateway, they see everything unencrypted, right? Like, so is the gateway a single point of security failure? Is there local storage for the gateway, or is it just serving as a proxy, just passing things back and forth? Is it encrypting things locally? Is there an anomaly detection capability in the gateway? So in a lot of IoT deployments, you'll have a lot of devices behind a gateway, and the center of the cloud won't actually be able to see the devices. You'll only be able to see reports from the gateways. The gateway's sort of like in a privileged location. What are the security implications of that privileged location? Can you learn anything from it? And is there a logic play? So the cloud implication, the cloud security considerations draw a lot on sort of traditional web interface best practices. Is there a secured web interface? Is there an insecure web interface? Is there a capability to do data classification and segregation? Or is all of your IoT data just thrown in the same database, right? So you're storing very sensitive stuff with not very sensitive stuff. And what does that mean? Does that mean like suddenly all of like my very mundane data I have to treat as very protected data because it's stored in the same place as the very protected data? Or do I just degrade my overall protection and sort of say like, well, we got secure stuff, but most of it doesn't matter, so we're just not going to protect it very much. Is there security embedded for it, right? So if you're going to attack an IoT system, attacking the edge is really easy, but attacking the center is really valuable. Right? Like, this is where all the data goes, and in many IoT deployments, the center is not only collecting information from the sensors, it's also sending out command and control to the sensors, and it can actually actuate them, update firmware, do that kind of thing. So a compromise at the center is particularly bad. You see this all over the place, where you'll see people build these IoT ecosystems, and they'll use secure tools, but then they'll use random third-party libraries to help support it, and it's like, okay, jQuery makes your web interface look awesome. Are you actually updating that? Like, do you have a capability to even list all of the third-party stuff, like all the software that your company is not directly responsible for, and report on its versioning? How do you update it? Do you have a plan for any of those updates? How will you respond if there's a vulnerability that's found in one of these supporting libraries? Is there any sort of audit capability, right? Can I tell which device did what when? If not, why not? Is it important? Is there interface segregation? And you rarely find this, right? So an autonomous device is going to send very predictable information to the cloud, right? And you're probably going to know what that is, and it's going to be doing very different for the human user. Is the interface at the center designed to be the same for the human user as for the device? And you see a lot of people do this when they develop systems for convenience, right? They develop one interface, and they have the device interact with it this way, and the human interact with it this way, and the mobile interact with it this way, but it doesn't take a tester long to figure out, like, oh, hey, I can pretend to be a device and get all sorts of interesting new interfaces and new capabilities. And do you have like complex multi-factor authentication, right? So we've got like a long history of providing good authentication and security on the web. You should be using it. Mobile considerations, I'm sort of going to skim over just because I think mobile security has been kind of done to death, and there's an OWASP mobile group that you can check out for better recommendations there. In general, you want to make sure that your mobile device is integrating the overall security of your platform. So sort of final thoughts is that privacy is a big deal. I think I've talked about that a lot. Strangely, the Federal Trade Commission is seeking feedback right now for proposed recommendations around IoT security best practice that they're going to release in January. They are probably going to outline the things that IoT manufacturers should be doing, and there are going to be fines associated with failure to comply. So I think we're going to see a big push in IoT security really soon, as soon as people understand what those recommendations are. And finally, consumers might not care about security, but businesses do. Like any sufficiently sized business, hopefully the places that you guys work, if somebody says, I want to do an IoT deployment, you're asking questions like, why? How are you going to make it secure, right? The kinds of things that most consumers won't. And OWASP is certainly not the only organization in this arena. There's Security Smart Cities, Build It Security, Build It Securely, the Online Trust Alliance, and probably I'm sure most of you have heard about Mind the Cavalry, which is started working mainly in the medical field, but it's also branched out into other IoT security. So I think I have like a few minutes left for questions. Yeah.
Pick it up. So a lot of what I do is prioritizing. So you raised my concern level around IoT, sort of there, but I feel like it's this plan, right? If we could do one thing, if you could advise me one thing I should do, what would that be? Sort of assessing the problem.
In terms of like bringing IoT into your organization?
I'm bringing it in. I have to bring it in.
Right.
Consumers, right, in
Yeah.
business are plugging in things that have these vulnerabilities.
Right.
So what chance do I? What's the one thing I should buy, implement, design, architect, whatever?
Right.
To hold me over until when I can do a proper assessment.
Right.
Consider.
So yeah, so this is going to be an exciting answer, but depends on that, right? That's really the first thing that you need to do when you're considering these kinds of things is say like, okay, assuming that I am bringing in a potentially vulnerable, unsafe component into my overall architecture, my IT ecosystem, why don't I just look at that component and think, what are the implications for compromise, and how can I limit the damage that I can do, right? So like a lot of people will they'll create a separate VLAN for their IoT environment, segregate that, create traffic restrictions, even just getting visibility into what the various IoT components in your infrastructure are will help you a lot. Figuring out what kinds of things those are doing, what kind of network communications those devices are making, looking for anomalies in those communications, making sure that they're not calling out for malware.ru or whatever. But you definitely want to sort of say like, okay, like people will classically say like security is only as strong as its weakest link, which is kind of true. But if you can isolate those links, you might be able to break one as an attacker, but you might not be able to allow it to the other links. And so that's the approach you need to take. It's like, how do I isolate this? Assume a compromise of this one link, and how do I limit the damage just to that?
Cost-wise, I mean, how do you justify it to the business? I mean, because most of us here probably don't work in a nuclear power plant, that's worth about,
Right.
nation-state attacks and whatnot. If the business sees it as like, okay, once in a blue moon, someone's going to flip on the coffee machine with no cup in it. I mean, how do you sell this to the business?
So it's actually easier than you would think, right? So you look at government regulations. So you look at fines that the Federal Communications Committee, the FCC, and the FTC, the Federal Trade Commission, Federal Communications Commission, have levied against businesses for failing to follow best practices, right? So the FTC has a really great white paper, I think it's like Start with Security, that's actually targeted towards startups, but they cite like 50 business cases where they find businesses for failing to follow best practices. And you go to your management and you say, look, the FTC is already fining people tens, if not hundreds of thousands of dollars for failing to follow best practices. With IoT, they're coming out with guidance in January. We should talk to legal, we should talk to compliance, we should get their readout on what they think those regulations are going to be. Because you might think it's just going to be, your coffee machine getting turned on, but the leaked Verizon report about the Target, compromise showed that internet connected meat slicers were an avenue into Target's ecosystem, right? So there are going to be consequences for failing to follow best practices in security. And I think if you look at government fines, that's a really easy sell, because you can sort of say, like, look, you as a business, if you don't address this, you're accepting certain risk and potential liability that could cost you something.
Is there currently like a IoT wall of shame, like a clown?
No, that's a good idea. Yeah, we should do that.
Okay.
Yeah, all right. Yeah, let's see.
I was just thinking about that same question. The scenario, I worked at a college, so the scenario for us, if the Internet of Things for us, it's like light and HVAC. So it becomes a cost issue. Say if those things are compromised, and somebody's turning on all the lights, burning out the lenses on projectors, things like that. You've got to, in terms of justification,
Right.
why you isolate these things. You can look. I don't want to be tripling or quadrupling my power usage for a building. I don't want to be these consumables.
Yeah. And I think it's important.
Coffee maker gets turned on at night, right? You might have to replace that every 6 months instead of every 2 years.
Yeah.
Things like that.
I think it's important to think more broadly, though, right? I think it's easy to look at an IoT environment and say, like, well, somebody compromises my light bulb, who cares, right? Like, the reality is, if somebody compromises that light bulb and uses it to do something else, like, that's where the FTC will come in and fine you.
Okay.
And you'd be like, well, it's just a light bulb, like, I didn't care. And it's like, sorry, you didn't apply security due diligence to your IT infrastructure uniformly, and you left certain very weak spots that attackers were able to use. And so, sorry, like, we're hitting you with a FERPA violation, right? Because you lost 20,000 student records, and they came in through your smart light bulb, but we don't care how they got it. We don't care about the end result. So that's the important thing to think about is like these components may seem stupid and worthless and like the damage is very limited, but it's important to sort of think more broadly about like these are components in a much larger ecosystem and they don't exist in isolation and their compromise might not initially seem like it would cause a big deal, but it might definitely. Yeah.
So, for example, I know light bulb is like kind of like a silly example, but if you're in a room with somebody who has epilepsy, and someone is spamming the light bulb on them, all that organization could get fined for that. So.
Yeah, I mean, there's all sorts of unintended consequences. I think I've really like. I'm not a fan of government regulation, but I think that the fact that the government is moving in this direction is a good tool for us in information security to go to management and say, look, there's going to be a financial risk associated with failure to address security in these deployments. So think more broadly than the coffee machine or the light bulb.
You mentioned legal ramifications and/or a financial risk, and that gets the business's attention.
Yes, exactly. Like so. It's been my experience that my best friends are the legal and the compliance department because I just go to them and I'm like risk, and they're like, I speak that language. I'll do that one. And suddenly there's board level meetings that I don't have to go to that they go to, and they basically bring my ammunition and say like, look, this is not a cool situation. So those folks are your friends, especially with IoT.
Yeah.
All right, well, I think that's about all the time we have. If you want to ask me questions offline, I'll hang out here for like another 5 minutes before I get kicked out by the next.